Welcome to this training course on BricsCAD BIM. Today we're going to talk a bit about MEP modeling. So in this section you will learn how to create piping and duct layouts using the built-in library of profiles. You'll learn how to work with the profiles dialog and panel, how to use direct modeling tools related to MEP, and even how to create duct layouts automatically. Let's open BricsCAD BIM. Okay, so today we're going to talk about linear solids. Linear solids are solids that are created by extruding a certain cross-section or profile along an axis. So some typical use cases for linear solids are pipes, ducts, but also beams and columns in the structural world. So that's why actually those two disciplines are combined together in this structural MEP tab in the ribbon, because there's actually a lot of overlap in functionality, at least when it comes to modeling them. Now we can see here in the ribbon there's the profiles command, which will open the profile dialog. So here we can see all the profiles, or cross sections as you could call them as well, that are shipped with BricsCAD. So there's different types: HVAC, piping, structural steel. Then within these types there are different standards. So for example, if I choose the structural steel, I can choose for the European standard, for example, and find all of the typical I-shape like IPE, HEA, and so on. So you can use this to filter for the types that you need. And then we can see here at the bottom there's the in project and in central database. So this is everything that's in the central database, so that's shipped with the product. You can add to this database so you can reuse everything in other projects. And then here we have the in project, so all the profiles that are currently used in this drawing or in this BSys lib actually, in this library for this project. And here on the right hand side we can see a little preview of the type or the shape with their different parameters. So if I select, let's say, IPE 160, I can see it has a height of 160 mil. Height is defined as distance between the top here and the bottom here, and so on. So that's the same for all the standard or default shapes. So for example, let me reset these filters here and go to piping. Pipes are hollow circles, and I can see all of these standard pipe shapes and sizes. You can create new profiles based on an existing shape, or you can just create a new shape based on polylines or other shapes in your model. Okay, so let's close this profiles dialog and take a look at the profiles panel, which is actually an abstraction of what we saw before. So it's basically the same information that you can find here, but it's more interactive with your modeling space, because let's say I take the piping here and I choose to show only the profiles of my project. From here I can now just simply drag and drop a shape into my model and start modeling. So this dragging and dropping has two different behaviors based on depending on what you do with it. If you just drag and drop it in your model space on just an empty space, you will actually launch the linear solid command. So you will start creating a linear solid with this profile, and you can start creating the axes as if you were drawing a line in 3D space. If you already have a line or a polyline or just some other line work in your drawing, you can drag and drop a profile onto that line and it will apply the profile onto that line. So then you're actually calling the apply profile command. Okay, let's take a look at the model here, and I can see I have several drawings attached into this drawing here. So architectural and structural. Let me turn off or unload the architectural model and the structural model so I can see more clearly what I'm doing. And I can see I have some terminals here, some toilets and urinals, some sinks, which need to be connected up with the main pipeline Let's isolate the hot water layer here. So I can get a clear view of what is already there. And I can see currently we have this red line here and some small pipe segments we need to connect up. As I told you before, we can drag and drop a profile onto an existing line and it will turn into a linear solid. So let's use this, this 3230 and just drag and drop it onto this existing line. Before pressing enter, it will show you a preview where the line is, in this case, in the center of my circle. And you can still choose to rotate the profile, quarter turn it. In this case, it's a circle, so that won't do much. So I'll just press OK, and then it applies this profile onto this line. I can get rid of the line if I want to. Now, this creates an object. It's a 3D solid, but it has a bit more information than that because it's actually a linear solid, so it knows the profile that is attached to it. And in this case, it's also automatically classified as a flow segment, which is the appropriate IFC type for pipes. All right. Now let's create a pipe going from here to here, so from point to point. And again, I will just drag and drop this in my model space. So now it's attached to my cursor. Let me snap from this point here, from this node. I will use snap tracking, just like I would do in 2D with 2D lines, to create this pipe. Now actually, so I created these two flow segments, this one here and the vertical one. But I can see in between that a flow fitting was created automatically based on some preset parameters that you can change. So it creates a new solid with some properties like the fitting radius, the tangent length, and so on, which you can change per fitting, or you can choose your general setting here under MEP. There are some flow fitting parameters such as the fitting radius, tangent length, reducer length, and T length. So those are the two basic ways of creating a linear solid. Now let's take a look at manipulating them or connecting existing segments. So for example, if I take a look here at where these two pipes come together, actually I created them independently from each other, which causes them to actually interfere in this location. There's a clash between the two pipes because they're not properly connected. So I can use the connect flow segments command, select both of the segments, and in this case it will modify this connecting pipe here so it fits to the other one properly, so it kind of moves around instead of clashing with it. Now let me undo this and let me enable another setting. So under BIM MEP, there is a setting called automatic tease. If I enable this, and if I now again do connect flow segments on these two entities, it will automatically create this extra flow fitting, a T, between these three pipes now. So now this one pipe is split up into two pipes, and a T was created in between. Again, with some properties like the tangent length. We can see that this T actually has three profiles because there's three pipes coming together, and you can see their profiles by cycling through the profile index here. In this case, all three are the same, of course. We can also use connect flow segments to connect, for example, these two, and automatically it will try to find a way to connect them like this. Sometimes you will have different variants to choose from, different variations. So I'll do the same for these and for these. And as you can see, again, automatically this T is created here because of my automatic T's setting. And I can do the same on the other side. So just selecting them and using connect flow segments. All right, let's take a look at this new piping layout that we added in context with the other ones. So let me unisolate the other layers. And I can see actually that my hot and cold water pipes are currently interfering. So they're in the exact same location here. So I will need to move my pipe upwards so they're no longer clashing. The way I can do that, the easiest way is by dragging them, let's say dragging one segment upwards. Now, if I want to drag this upwards, I can either use the manipulator and start moving it like this. And as you can see, all of the other connected pipes will stay connected. So at the bottom here, those vertical pipes will lengthen, and the other horizontal pipes will also move with it. So that's one way of doing it, using the manipulator. Or I can actually use the drag command. And to use that, I will need to enable my sides and ends. So this is actually it's a special selection mode that works with linear solids. So if I enable this and I move my cursor over, let's say this pipe segment here, I will see, instead of highlighting the actual cylindrical face of the pipe, I get this horizontal, or if I move my camera here, this vertical side face, in this case top face, that I can start manipulating. So I can highlight this top face and use the drag tool to achieve the same result. So it's just kind of a special selection mode to help you highlight or select side or top faces of linear solids. Okay, so let me just move this up, let's say over a distance of 50 mil. And now it's no longer clashing. Now we can still, of course, change the profile of pipes. So for example, these two pipes here, I want them to have a larger diameter because two pipes come together in this one. So let's go to the profiles library and just apply this 40 mil profile. Now before pressing enter, I get this preview again, or you can choose to apply. In this case, I'll press enter. And you see here that these T's automatically became reducers. So if I go in top view, you can clearly see that they become wider. So it's a reducer and a T in one. So depending on the situation, it will create new reducers in between, or turn existing fittings like these ones into reducers. Okay, let's take a look at an example of HVAC. Let me go to my layers here and turn on my terminals layer here. And actually, I will isolate it. So I have here a grid of flow terminals or air terminals in the ceiling that I want to connect together now. Now, flow terminals, just like pipes and ducts, can have a profile, or to be more precise, they can have flow connection points inside them that indicate where a connection will be made with the outside world. And that flow connection point can contain information about the type of profile that can be attached to it. So let me open this flow terminal here, open a copy. It's just some geometry to indicate what the flow terminal looks like, but it also contains this one flow connection point, which in this case is simply a circle classified as a flow connection point with a certain profile attached to it. If you want to make your own flow terminals with connection points, our library actually contains some MEP flow connection points that you can just drag and drop onto existing flow terminals like this. And once you've inserted it, you can start to indicate a profile like this. Alright, so let me close this drawing here and go back to our main drawing. So each of these air terminals here has a profile attached to it. And there's also this main unit here which has a different profile attached to it, a rectangular duct in this case. Now, when flow terminals like this have a profile information attached to it, we can actually use connect flow segments to automatically create a layout of ducts or pipes in between. Especially in this case where everything is laid out in a grid, it's quite easy for the software to understand how it should be create or linked together using connect flow segments. So before I do that, I will actually first reload my two XREFs and unisolate. And I'll go in X-ray mode so I can see a bit better inside here. So I want to select all of my flow terminals, so these guys, as well as my main unit here. And I want to start connecting them. I will turn this V duct or ventilation duct layer as my current layer so I can see more clearly what I'm doing. And I will now use the connect flow segments command to create a layout for us automatically. So I can see here that the layout is created. It's still a preview, just in pink line, which is my layer color. And I can see I can press Control to switch to the next alternative. So it finds different alternatives, and you can cycle between them to choose the one that you find most suitable. So if we choose this one, for example, I can hit Enter to accept, and it will then create a 3D model of this layout based on the profile information that was inside these flow terminals. So rectangular duct for this one here, round ducts for the smaller terminals. And at one point it chooses to branch off from the main duct to smaller ducts here. I can still choose to tune this, either the topology or the height. So topology is what we saw before, so the 4 variations that we saw, we can still pick another variation. And I can choose also to change the height. So I can individually select lines to change the height from, but then actually in this case I will select the entire top part here, and I will move this entire layout up or down a bit. So let's move it over a distance of 1050 mil, like this. And we can choose to finish. And that will actually create this ductwork for me automatically. Alright, so that's done. Let me turn off my architectural model so I can see a bit more clearly what's going on. Like this. Let's go back to BIM, or let's say modeling visual style. Okay, so it looks like all my air terminals are now connected up to the main unit. Although I can also see that my main ducts here are clashing with the structure, so the steel structure is clearly clashing here, so we can again choose to adapt our layout a bit so it doesn't clash anymore. So again, I can use the manipulator like I showed you before. Like this. So let's choose 500 mil. So now we're no longer clashing with the columns. And I'll do the same for this one here. So manipulator, or I can use the drag function. It will have the same effect in this case. Okay, that's everything for this module on MEP modeling. So we explained how to use the profiles panel, profiles library, how modeling with linear solids works, what you can do with those modeling tools, how to create a piping layout and duct layout, and even how to automatically create a layout based on a grid of terminals. Thanks for watching. I hope you found it helpful, and I'll see you in the next session.